Assalamualaikum. Today I will present the proposed 4-story academic block located at EDU City Iskandar Puteri, Johor. This building is designed to support teaching and learning activities. It includes facilities such as classroom, lecture rooms, academic office, laboratories, and student spaces. For this project, the focus is on the reinforced concrete upper floor slab. This structural element is important because it contributes for the safety, durability, and overall performance of the building. The main structural component of the building consists of columns, beams, slab, and staircase. These components work together to ensure the building remains stable and safe. The upper floor slab carries load from equipment, furniture, equipment, and building finishes. The load are transferred from the slab to the beam, then to the columns, and finally to the foundation. For this building, the selected slab system is two-way solid reinforced concrete slab because it can distributes loads efficiently in two directions and provides good structural performance. The two-way solid reinforced concrete slab has several important characteristics. Firstly, it distributes loads in two directions, allowing loads to be shared more evenly among the supporting beams. Secondly, it provides high structural strength through the combination of concrete and steel reinforcement. The reinforcement also helps minimize cracking and improve load resistance. Another important characteristic is fire resistance, as concrete naturally provides protection against high temperature and improve building safety. Then, advantages and limitations. The selected slab system offers several advantages. It provides efficient load, distributes high strength and good durability, and excellent fire resistance. These qualities make it suitable for classroom, lecture halls, office, and other educational spaces. However, these are also some limitations. The slab requires a larger amount of the concrete and steel reinforcement, which may increase construction costs.
For this section, I will explain the category of slabs selected for the proposed 4-story educational building. The selected category is the two-way reinforced concrete slab. A two-way slab is supported on all four sides and transfers loads in two directions. This enables the slab to distribute loads more efficiently to the supporting beams and columns. In addition, reinforcement bars are provided in both directions to resist bending moments and improve structural performance. Due to its stability and efficient load distribution, the two-way slab is widely used in educational buildings such as schools, colleges, and university academic blocks. Therefore, the two-way slab is considered suitable for the proposed educational building. Next, I will explain the type of slab selected for the proposed building. The selected type is the solid reinforced concrete slab. This slab is constructed using concrete and steel reinforcement bars cast in situ at the construction site. A solid slab has a uniform thickness throughout and does not contain any hollow section or voids. It acts as a horizontal structural member that transfers loads and occupants, furniture, and equipment to the supporting beams and columns. This type of slab is widely used in Malaysia because it is durable, reliable, and provides good fire resistance. Therefore, it is suitable for educational buildings that require long-term structural performance and safety. There are several reasons for selecting the two-way solid reinforced concrete slab for the proposed educational building. Firstly, it provides efficient load distribution because loads are transferred in two directions, resulting in better structural performance. Secondly, it is suitable for educational buildings such as classrooms, lecture halls, and laboratories, which are required to support moderate to heavy occupancy loads. Thirdly, the slab offers greater structural stability and rigidity by reducing excessive deflection and improving load transfer. Furthermore, reinforced concrete is highly durable and provides excellent fire resistance, making it suitable for long-term use. Lastly, the materials and construction methods are commonly available in Malaysia, making the slab system economical and practical. Compared to one-way slab, a two-way slab provides better load distribution and structural efficiency, making it a more suitable choice for the proposed building. The selected slab offers several advantages. Firstly, it provides efficient load distribution in two directions, resulting in improved structural performance. The slab also has high strength and rigidity, making it suitable for educational buildings. In addition, reinforced concrete is durable, fire resistant, and has a long service life. The slab system is also widely used in the construction industry, making it practical and reliable. Despite its advantages, the selected slab has also several disadvantages. The slab requires more reinforcement compared to a one-way slab, which may increase construction costs. In addition, it has a higher self-weight, resulting in greater loads being transferred to the supporting structure. The construction process also requires extensive formwork and temporary supports. Furthermore, additional time is needed for concrete curing before the slab can achieve its required strength. However, these disadvantages are generally outweighed by the structural benefits provided by the slab system.
For my part, I will be explaining about the construction stages. The construction stages has 7 stages. Start with formwork installation, reinforcement installation, concrete pouring, concrete compaction, finishing work curing process, and the formwork removal. So let's start with formwork installation. First, the formwork is first installed to support the fresh concrete until it hardens. Then the slab size and level are checked thoroughly before the work begins. After that, props and supports are placed inside the formwork to carry the concrete load. The formwork then is cleaned and coated with release oil. So by the time the concrete hardens, it is easier to take off the formwork. The tools that we use for this stage is measuring tape, spirit level, hammer, steel props, and power drill. The steel props are used to hold the formwork, slab, beam, and wall. The second step is reinforcement installation. First, reinforcement bars are placed according to the drawing, and then the bars are tied together using a binding wire. And then the chairs and spaces are used to maintain the required concrete cover. And then lastly, the reinforcement is inspected before concreting in case there are anything that is going wrong, so we can detect it early so we can fix it. And then the tools that are used to install the reinforcement bar is the bar cutter, bar bending machine, pliers, and then a measuring tape. The third step is concrete pouring. First, the concrete is delivered by mixer trucks and then got pumped on the slab area. Then the concrete poured evenly across the slab. Lastly, the worker ensure that all reinforcement is properly covered by the concrete so it doesn't miss a spot. The tools and transportation that are used is a transit mixer truck, a concrete pump, and a shovel. A concrete pump is a machine that pours concrete straight from mixer trucks. It is usually used inside, so it is easier to move around. The fourth stage is concrete compaction. The concrete compaction starts when the concrete is ensured that it is compacted already, and then they use the vibrators to remove the air pockets. A proper compaction increases strength and durability, but over vibration is avoided to prevent segregation on the concrete. The tools that are used here is a poker vibrator, safety glove, and safety boots. We use safety gloves to protect ourselves from chemical burn by wet concrete. It is highly alkaline when it's not fully dried. And then we also use the glove to prevent from getting cuts, vibration, and vibration because it causes fatigue for the worker. And then we need boots to protect us from crash protection and the machine might get on our foot. And then same as the safety glove for chemical protection reason. It is also puncture resistant because at side there are like a lot of sharp things and materials like nails, and it protects us from falling debris to case. And then lastly, it prevents us from sleeping while doing the concrete compaction. And then we're moving on to finishing work, which when the concrete surface is leveled and then smooth out. First, we scrape and trowel them to create a uniform finish so it looks even. Any surface defect that are found is required to be corrected before the concrete sets. So if there's any mistake, we must fix it instantly before the concrete dries out. For tools, we use scrape board, bull float, and hand trowel. All of these are the same thing that are used to make the concrete even. Is this the scrape board? Is like a long wood that are used to make the concrete even, and then the bull float is like a steel sweep, and then a hand trowel is the small thing that we use to make the concrete even. And then we have a curing process. The curing process is to make sure that the concrete stay moist even after the concrete sets. We use water, wet burlap, or plastic for curing. By curing, it helps to improve strength and then it prevents the concrete from cracking. The tools that are usually used is water hose, sprayer, wet burlap. A wet burlap is like a wet blanket that we lay down on the concrete so it stays moist. And lastly, we have a formwork removal. The formwork is removed after the concrete gains sufficient strength, and then the slab is inspected first to detect if there's any crack or defect on the concrete. And lastly, if there's a minor repair, it is usually carried out by the team because we don't want any mistake. For the tools that are used to remove the formwork is hammer, crowbar, spanner, and safety helmet. We usually use safety helmet to protect your head from traumatic brain injuries that are caused by falling debris, swinging equipment, or any structural collapse.
As Shazana has been explained about construction process of reinforced concrete slab, we go to the annotated isometric sketches. Firstly, we have figure 1, isometric sketches of formwork arrangement. Next, figure 2, isometric sketch of reinforcement layout. Figure 3, isometric sketch of concrete pouring process. And lastly, figure 4, isometric sketch of completed two-way RC slab structure.
So that's the overall of our report. So in conclusion, the two-way solid RC slab that are chosen by us is really suitable for system type, especially for an educational building. Well, this is mainly because they provide good strength, stability, and durability, while making sure it is safe for everyday use, especially when there's student and the staff. The construction process involves several stages, including formwork, reinforcement, concrete pouring, curing, and then the formwork removal itself. Overall, this slab chosen is proven that it is a practical choice because it meets all the building structural requirements while it also provides a long-term performance. That's all. Thank you.